Hello, testing, testing. One, two. Very funny, right? Testing. Why do I come up with this? Okay, so trying to keep it light because testing is, it's not the most exciting thing we're going to learn. Great introduction. In this video, we're going to talk about a statement in Python called the assert statement. It allows us to assert that certain expressions must be true, and if they are not, it will throw an assert error. So it accepts an expression like, let's say we had a function called add, keep coming back to this basic function, and it takes in two numbers, num1 and num2. We could write an assert to make sure that num1 is an int, or that num1 is positive, or whatever we want, some expression. And if it's false, it will throw an assert error. It returns none if the expression is truthy, so it does nothing. And it raises an assertion error if the expression is falsy. I think I said assert error earlier, assertion error. And finally, we can specify a second argument, an optional error message. And before I even dive into the code, before I show you any examples, let me just start by saying that assert is useful. It has its uses, but it is not the end-all be-all to writing tests, at least not nowadays. I do believe that it used to be a lot more commonly used. It was sort of the granddaddy. I think it's been grandfathered in from languages like C, but there's a big shortcoming, which is that we can ignore all the assert statements in an application with a single line of code. When we run the Python file, we can ignore everything in there. And that could cause a lot of problems with our tests. So my opinion is that you shouldn't use assert to test all of your code. I can point out a couple situations where you might want to use it, but I'm just going to show it to you because it's an option at your disposal. But there are better options now, including things like unit test, which we'll take a look at in 2 videos from now. So on to assert. The syntax just looks like this. I have a function called add positive numbers. And the whole idea is that we want to test to make sure that the numbers that are passed in, x and y, are both positive. The first thing I'll mention is that assert is not a function. I've been very careful to say assert statement. And this kind of, I don't know if I'm missing something, it's kind of annoying to me because back in Python 2, print, for example, was a statement, and so was raise, and they've now been changed to functions. Print is a function, we need parens. Assert was a statement, but it still is a statement. I'm not sure why. I haven't dug into it, so I don't know why. But you don't need parens. It's not a function. It's a statement. Okay, so we call assert and then an expression. So if this is true, then nothing happens. We just move on to this. If this is false, however, whatever is after the comma is a little error message that's optional. So whether that's there or not, if this is false, it raises an assertion error, which is what you see here, assertion error. And if we specify a little message, you can see it says both numbers must be positive, which is the message we specified. Okay, and that's kind of it to assert. You type assert, and then an expression, and then an optional error message. Okay, I've made a file, just pasted the code in, and this file is called assertions.py. And as I said, if we run this right now, you should see, let's do a print on the first one. Just like this. If we call 1 and 1, we should get 2. If I call 1 and -1, we won't get 0. We'll get an assertion error. So if I run the file, python3, assertions.py, first one works, and then we get this assertion error. Both numbers must be positive. So you can think of assert as basically if some expression is, well, let's just say if not some expression. This is not going to be valid code, but if not some valid expression, then raise, assertion error. Like that. Essentially, that's what it is, except for the fact that it can be overridden. All the assertions, all the assert statements will not run if we run our code in something called optimized mode. I'll show you later in this video. So there's that slight difference. If I ran, assert 4 equals 4, that's true, we don't get anything. But if I run 4 equals 2, it raises assertion error. So if this is false, it raises an assertion error. And if I added a comma, and then 4 should not equal 2, assertion error, 4 should not equal 2. Back here in the same file, I will comment this out. Let's say I'm going to define a function called eatJunk. And eatJunk takes a single string argument called food. And the whole idea is that it's really silly, but we're going to just make sure that food is a junk food. So it's either candy or ice cream or pizza, something like that. And at the end, we'll just return an F string that says like nom nom nom, I am eating, and then food. But like I said, we want to verify that it is, let's say it's either pizza or ice cream, candy, or fried butter, which is a real thing. Okay, so to write the assert statement, it's assert food in, this is our expression, this is true or false. Food is either in there or it's not in there. Do I have a space? Now I do. And then we can provide an optional message, but this is going to be a pretty long line, so I think I would prefer to break this up, do our strings like this. There we go. Totally optional. Assert food is in this list, and then we'll say the error message is food must be a junk food, like that. Okay, then down here, let's just ask a user for input. Enter a food, please. And then we'll just call eat junk and pass in food. And let's print the whole thing. So we have this super simple function with an assert, and then we're asking a user for input and then passing it in, printing the result. Now, when I run it, it asks me for food. If I enter pizza, good, we're good to go. If I enter, let's go with kale, we get assertion error. Food must be a junk food. And that's working great, how it should work. That brings us to our next slide, assertions warning. So if a Python file is run with the -O, capital O, not 0, it stands for optimize or optimization mode, opta something mode. What it will do is, it does a couple of other things, but one of the things it does is ignore all assertions, which is not good. So let me show that to you now. If I do Python 3 capital O, the same code, please enter a food, and if I do kale again, I get nom nom nom, I'm eating kale. So totally ignored that assertion. And if I had code where I was using assert statements exclusively to test my code, and it was a real app, and not just a junk food function, that could be a problem. To demonstrate why this could be bad, I have a bit of a fantastical scenario down here. I've written pseudocode, but imagine that we have some real code in an application to check if there's an assert statement to check if a user is an admin. And if the user is an admin, they can destroy a bunch of things. They can remove posts. They can do whatever they want. They can delete our database. That's encapsulated by destroy a bunch of stuff. But I have an assert in here, so I should be good to go, right? I'm checking, is user that's being passed in, is the isAdmin attribute true? And if it is, then we're good. If it's not, then we should raise that assertion error, right? Well, if you ran your code with capital O or somebody else did, that would not run at all. It just ignores this line. So anybody could destroy a bunch of stuff. It's a simplified example here, but the underlying idea holds true, no matter how large or small the code base is. If you depend on assert statements, well, you can't depend on them because they may not run. So that's the moral of it. Asserts can be nice and they can be useful, but you cannot count on them to run. They're not guaranteed to run because there's a loophole deliberately designed in there. I'm not sure why, to be honest, because as far as I've read, optimized mode is not actually all that optimized anyways. People complain about it all the time. But anyway, I am getting a bit off track here. We will see a better alternative. Okay, I'll end the video here.